Now we're going to look at the midsegment of a trapezoid. So this is called the trapezoid midsegment theorem, and it basically says that this midsegment here, kind of like a triangle midsegment, is the average of the two bases. So it's not really that it's half of one base or half of the other, but you take half of one and add it to half of the other, and you get the midsegment. So why does that work? Well, first of all, I'm going to go ahead and write down my given. I know my two bases are parallel, and since these are midpoints, AE is congruent to ED, and BF is congruent to FC. Now I'm saying that if AB is parallel to DC, and these are midpoints, do you remember the two transversal proportionality corollary, which said, okay, if these are all parallel, they cut them proportionally. Well, I'm saying, hey, these are cut proportionally, so all of these must be parallel. So I can say that EF is also parallel to the other two segments. Now, if I'm going to go ahead and add a line here and add this point M at the intersection. This length here, EM, if you look at it, that's an upside down triangle. Well, it's a triangle either way. And this is the midsegment of a triangle. And we said the midsegment is half of the base. So using the triangle midsegment theorem, I can say EM is AB divided by 2. Similarly, I can do for FM that it's half of CD using the triangle midsegment theorem. Okay, then using the segment addition postulate that this yellow piece plus that green piece is EF, I can say AB over 2 plus DC over 2, that is EF, which actually turns into that formula right there. One base plus the other base divided by 2. Now we're going to go ahead and apply the midsegment theorem. So I'm going to write it down. The midsegment, you add both bases and divide by 2. So you're probably saying, hey, this is pretty easy. And it is. 4.6 plus 5.32, 9.92 divided by 2 is 4.96. So that is extremely easy if I give you the two bases. It gets a little more complicated on this next example where I give you the midsegment in only one of the bases. So I'm going to write down the formula again. The midsegment is the sum of the two bases divided by 2. Okay, so now remember you need to be able to substitute into the left side of the formula just as much as the right. EF is 6.59. I'm going to leave AB there because I don't know what it is. And DC is 7.48. Now to make my life easier, I'm going to multiply both sides by 2 so I don't have this denominator bothering me. So basically those two cancel to 1, right? And then I get 13.18 equals AB plus 7.48. Subtract 7.48 from both sides, and I get the length of the base AB is 5.7. So it really wasn't too bad as long as you know to substitute into that left side. Now we're going to do one where we're going to determine an expression for EF. So again, I'm going to write down my formula, and I love to write equations, so I know that's not an expression, but we'll get there. So EF is the sum of the two bases divided by 2. Well, I'm going to put in the 2n minus 4 in for AB, and the 4n plus 8 in for DC. Combine my like terms, 6n plus 4, all over 2, and I can break this up into two fractions, 6n over 2 plus 4 over 2, which is 3n plus 2. Now there's an interesting thing here. What do you think is halfway between 2n and 4n? Oh, that's 3n. What do you think is halfway between 8 and negative 4? A little harder to figure out, but it's actually 2. So you could almost look at it, if I had said like this top base was 10 and the bottom base was 20, what's halfway between that? 15. So if you're just looking for the midsegment, there are some neat shortcuts you can use. So for further reflection, how could we have rewritten the trapezoid midsegment theorem using base 1 and base 2? Remember, you had base 1 and base 2 in your area formula for a trapezoid, and you might see an interesting relationship there. What are some strategies to determine a base when you know the midsegment and the other base? And what is the difference between an expression and an equation? Hopefully you remember the equation has the equal and two sides, and an expression is just something written out that may or may not be equal to something else. It's just by itself.